Welcome back to Structural Concepts in Arithmetic. In this video we are going to continue our discussion of the place value process, and we're going to talk about the important concept of rebundling and unbundling. Okay, so the basics of the place value system, things like counting by tens, 10, 20, 30, 40, 50, like that, don't really involve taking a bundle of units and trading them in for a new denomination. So that's another level that students have to master in the K3 curriculum to understand the place value system. And we're going to talk about some of the nuances of that. So let's switch over to the document camera. Okay, so we don't want that. Okay, so the key ideas here are understanding rebundling and unbundling, and the key idea of making tens, and you really want to look out for special combinations that do that. Okay, so harder place value problems involve recomposing and decomposing groups in various denominations. Let me try to explain what I mean with a couple of examples. Okay, so this is what I would consider this an easy problem. We can do it with the chip model. Okay, we only need 2 trays for this because we only got 10s and 1s. Okay, so we load in the 26. 1, 2, 3, 4, 5, 6. There's the 26. Now load in the 31. 1, 2, 3, and 1. Okay, so we can see here we have 5 in the 10s tray, and we have 7 in the 1s tray. So the result is 57. Okay, now this, even though it actually involves a smaller number down here, it's actually a harder problem, because it's going to involve some regrouping. So let's look at how we can demonstrate this in the chip model. Let's get the 10s tray and the 1s tray. Okay, now we can start out in the exact same way. We load in each one. Okay, we load in the 27. 1, 2, 3, 4, 5, 6, 7. And then let's load in the 14. 1, 2, 3, 4. Okay, now here's our problem. I have 3 10s, that's actually fine, but look at how many 1s I've got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 1s. Okay, I can't have that. What I need to do is I need to take 10 of those and trade them in for another of the 10s. Okay, so those are going away. Okay, so the result here is actually 41. Okay, now if we think about kind of the standard algorithm, right, you would have 11 here and you would carry 1 over. All right, so this rebundling is the carrying process that we know from the standard pencil and paper algorithm for addition. Okay, so when you're doing an addition problem, you might have to do some rebundling. Now, if you're doing a subtraction problem, you might need to do some debundling. Okay, so let's look at a quick example of that. Okay, so here I've got 2 subtraction problems, one easy, one hard. Okay, so let's look at the easy problem in the chip model. Okay, so if you're doing a subtraction problem in the chip model, you first load in that 36, the top number. Okay, and then you don't put in new chips, of course, right? This isn't an addition problem, it's a subtraction problem. And if you think back to grade school, right, some people would even say 36 take away 21. Okay, so we're not going to be putting in new chips, we're going to be taking away chips that we already have. Okay, so from the ones position we take away 1, so scratch that out. And from the tens we take away 2. Easy. So we're left with 1, 5. Okay, so the answer is 15. And we can see that from the chip model. Okay, now this is a harder problem. Let's see why. So once again, we'll load in the 32 on the chip model. I tell you what, let's change the problem a little bit here. This is going to involve a subtlety that I don't really want to deal with, so let's make it 52. In fact, let's change it again. Let's make it 42. Okay, we're going to do 42 minus 26. Okay, so we got 42 loaded in there. All right, so we got 4 tens, we want to take away 2. That's easy. Okay, the problem is right here. We got 2 ones, we want to take away 6. So right now, we can't take away 6. Okay, so what we're going to do is we're going to have to cash in one of the tens. Okay, and give us, now we've got 12 things over here. Now we can take away 6. 1, 2, 3, 4, 5, 6 are taken away. Okay, so we can see what we're left with in the model. We're actually left with 1 of the tens and 1, 2, 3, 4, 5, 6. Okay, so 42 minus 26 leaves us with 16. Okay, so this is an example of what we often call borrowing in the standard algorithm. Okay, we only had 2 chips in the ones place, but we needed to take away 6. So we had to cash in one of our tens, giving us enough chips over here to take away the 6. Okay, so this chip model gives us a really good example of how to use this unbundling or decomposing or whatever you want to call it. Okay, now something you need to keep an eye out for when you're doing these problems are these tens combinations. Okay, so you got to look for pairs that add up to 10. So you're talking about 9 and 1, 8 and 2, 7 and 3, 6 and 4, and 5 and 5. Okay, you've got to have these kind of handy for unbundling and rebundling. Okay, so they help with unbundling and rebundling when we're doing arithmetic. So for example, if I wanted to do 47 plus 8, okay, I don't really visualize it as an 8, okay. I'm thinking, all right, I got 47 plus 3 plus 5, okay. I don't think of it as 8, I think of it as 3 plus 5. Okay, now, what difference does that make? Well, now, 7 plus 3, that gives me a 10 combination. Okay, 47 plus 3, that gets me up to 50. Plus the 5 additional that I had over here. Okay, so noticing that 10 combination basically lets me do this problem in my head. Okay, I don't have to sit here and carry over as long as I recognize that 10 combination. Okay, you can do it in subtraction too. Let's do let's do 60 minus 8. Okay, we'll think of a 10 combination. Okay, now 10 minus 8, I know that's 2. Okay, so 52. Okay, so this is kind of decomposing. I took out one of my 10s to deal with this 8. Okay, and knowing your 10 combinations helps out a lot when you're doing arithmetic like this.